So now we're going to start getting into how we're going to actually graph these polynomial functions. One of the big concepts is the end behavior, and that's going to give a lot of the shape of our polynomial graphs. Well, what do I mean by end behavior? Well, with polynomial functions, what it's going to come down to is that bigger exponents get bigger faster. Now, what do I mean by that? As usual, I think an example will clarify this nicely. Let's go ahead and look at a relatively small x value, f of 1. So that's going to be in the middle of our graph. And we're going to find that these values here, the terms, term 1, term 2, and term 3, are relatively close together. Right? In fact, the constant ends up being the biggest value here. However, what if I put in 10 instead? Well, looking at this, if I am worried about any of these terms, well, this $30,000 here, if I've got $30,000, not to say that 200 isn't worth much, but that doesn't really matter that much. So let's go ahead and take this even a step further, and let's look at what happens when we plug in 1,000. All right, now looking at this example, while this 2 million here might seem fairly big, well, if I correct my commas here, we're going to see that here we've got what that would be millions, billions, trillions, 3 trillion. So if you have $3 trillion, that's actually a case where 2 million bucks really wouldn't matter too much. So what we're going to find is if we look at the limit, okay, as x approaches infinity, and that could be infinity or it could be negative infinity. I didn't put negative numbers in there, but it works similarly. What's going to happen is f of x, our function here, is going to approach 3x to the 4th. So in other words, all those other terms aren't really going to matter, okay? So we're just going to look at the big power for this. That's kind of what you need to get out of all of this. And if that's the case, then we end up with 4 distinct cases. So let's look at those cases real quick. All right, so let's go through these examples and keep in mind that, again, this is end behavior. Remember, when we looked at the middle of our graph, when x was equal to 1, all the values were pretty similar. So this behavior is only going to work when we start getting really positive or negative x values. Okay, so it'll be our end behavior. Now, the first one here, we're saying that x is being raised to an even power, that our polynomial is an even degree. Well, I'm also saying that a is positive. So I'm saying that I'm going to take a positive number, okay, and I am going to then take x, okay, and raise it to an even number. So as x approaches negative infinity, so if x is negative and I raise it to an even power, then I'm going to get a positive times a positive, and that's going to give me a positive. So that means that it's going to go up. Now, by the same token, if I change that to x is a positive value, well, then I'm raising that to an even power. I'm still going to get a positive, so I'm going to be going up as well. So these graphs, the middle ends up looking something like that, end up going up to the left and right. Now, by the same token, this other one we have here, in this case, a is going to be negative. So I'm going to end up with a negative times, let's say, a negative to the even power. Well, that's going to end up just being a negative times a positive, which is, of course, negative. So that means as x gets more and more negative, or as I travel to the left, I'm going to be going down. Well, what if I change that to a positive? Well, a positive number to an even power is still going to be positive, so nothing changes. So as x gets more positive, I'm still going to be going down. And again, the middle of the graph, depending on what it ends up looking like, will look something like this. Now the odd powers, as you might have guessed, are going to be a little trickier. Okay, so here I'm saying that I know that A is positive. Okay, and then as I travel to the left, so I'm going to have negative x values, and I raise that to an odd power. Well, a negative value raised to the odd power is going to remain negative. And a positive times a negative is negative. So as x gets more and more negative here, I'm going to be traveling down. But if I do it the other way, so again, A is still positive times x, which in this case would be positive, raised to an odd power. Well, that's going to be a positive times a positive, which is of course positive. So as x gets more and more positive, I'm going to be going up. And as you can imagine, the middle of the graph is going to look something like that. We can use that logic one more time, and that is here A is going to be negative. So I'm going to have a negative times a, well, as I travel to the left, I'm going to have a negative times a negative to the odd power. Well, that's going to be a negative times a negative, which is going to be, in this case, positive. So as I travel to the left, in this case, I'm going to go up. So here, if I do that same thing one more time, I've got a negative, and now I'm traveling to the right. So I need a positive x value, okay, raised to the odd power. Well, that's going to be a negative times a positive, which is, of course, negative. So in this case, as I travel to the right, as x gets more positive, I'm going to be traveling down. And we'll use the zeros to determine what the middle behavior is. So just kind of summarizing that real quick, what you basically want to do is to figure out the left behavior. Think of what will happen if x is a negative. And if you want to figure out your right end behavior, think about what's going to happen if x is positive. And when I say what's going to happen, I of course mean, are we going to be going up or down? Are we going to be getting positive values when we plug in a negative x? Or are we going to be getting negative values when we plug in a negative x?